Hello everyone, this is Team Quasar and this is our project Dataverse, a custom blockchain for secure data trading and data authenticity. So we are a team of two, Ankit who worked on front end and designing. I worked on creating custom blockchain using Hyper SDK and the firmware part. So we live in a society where almost everything is automated, and in the industry especially, everything is automated, and this automation is generally done via smart devices or robots. And these smart devices, robots, and IoT devices generally create a huge amount of data. And basically this data is very useful for other companies for data analytics. But the thing is, there are some challenges with the data that is produced. First thing is lack of data integrity, because if two parties are exchanging data, then they have to trust each other. And basically the trust is very less. This is what blockchain solves. And so the thing is, in nowadays also there's data trading happening, but and not at very large scale, because people don't or companies don't trust each other, especially the data sources, the lack of integrity in the data, the lack of trustness about the source of the data. It's like anybody can create a JSON file and then mark that okay, this is the real data. We don't want that to happen. We want a secure mechanism which can through which you can see that okay, this data is generated from a valid source, as well as this data is a valid data set, right? So the architecture to solve this is basically a Dataverse ledger. It's a combination of the firmware as well as the blockchain. So here you can see basically we have a firmware creation process in which okay, so firmware creation process, this firmware basically is a fork of Tasmota, which is a widely used custom firmware in the industry for home automation. So we have a raw firmware file. We forked it, we customize it so that it can interact with Dataverse ledger. For this demonstration, we have a machine ID attestation where we burn the machine ID into the firmware so that it can only be burned once, and it cannot be changed afterwards. This is basically the identity of that device, and this is given by the company. And it is very easy. You can do this through our dashboard into data ledger. So this machine ID is basically logged into or notarized into the data ledger chain, and you cannot fake it, right? So once the ID is created, CID is created for this machine, now you create a mnemonic through which you will interact with the chain, basically your wallet, and then you have a public key for that wallet. Then this attestation process where you map this public key with this machine ID both into the chain again, and this will ensure that okay, the device which is interacting with the chain is valid, has a valid wallet, as well as has a valid identity, right? And this device can be connected to any other sources like meters or any other data sources, right? So here you first register the machine, you attest the machine, and then you start notarizing the data, basically normal JSON files. You have your JSON data created in the device. Then what you do, you create a CID of the device in the firmware, in the device itself. You create a CID for that device, which is content identifier. It's actually IPFS standard. You create that CID, and then you sign that CID with your machine ID, and then you log it to the Dataverse ledger. So basically signing it makes that data authentic, and then the notarization is done on chain. Now you can store your whole JSON data, big amount of data, into your normal local cloud, or your basically any cloud provider. This depends on the company. It doesn't matter. They can easily change it based on what they want. It's actually device configuration. So the data notarization is very lightweight, where you have only one CID, right? So now the data is locked. Cool. So here we have three chain states. So these chain states are basically, first one is for tokenomics. Basically, when you trade the data, you send tokens to other company, right? So this is basically native token VM implementation that is already done by Hyper SDK, right? Second one is machine chain state, which stores all the test machine IDs and registered machines CIDs. Third one is data state chain, which is basically notarizes all your data. So these three basically have their own ups and downs. Basically, this one is very highly scalable, but less secure, and this one is very immutable. These are the things. The fourth, so the second last thing is the data validator. So when a device logs the data to the data ledger chain, so now they have to perform a consensus mechanism, complete the consensus mechanism, where the data validators they pull random CIDs from the chain, and then they query the creator of the chain ID to give them the data. So now they will randomly pick the CID, using MQTT call the device, and then ask for a data. So where is the data for this device? So this device will give the data for that CID, and then this validator will take the data and calculate if it is actually a valid data, and if it fails, then this data validator will remove this device and slash all the stake of this device into the network. So this is how the whole network is secure. Now that you have your produced data, now you can share it with your other companies, and then they will quickly pull the data into their node, and they can easily verify the data to the chain. This is very high performance because we are using Hyper SDK, and it's the transaction per second is very high. We were shocked by it, and actually it was very easy to create the chain. Considering other frameworks also, it was very easy. It took us only 3 days to create the whole chain, right? So thank you. Now let's move to the demo part.
So now let's see how a device can connect to Dataverse Ledger. For this, we have built a custom firmware using Tasmota, which is a widely used home automation software firmware for smart devices. So as you can see, we have this Sonoff device, and it is actually currently connected with my bulb. But in the industry, this device can change, but the main concept of notarization and all these things will remain same. And for now, I have only this device, so that's why I can show you with this Sonoff. So now this is the Tasmota firmware, and now you just have to click on firmware upgrade and use our Dataverse custom upgrade on top of this Tasmota to connect with our Hyper SDK VM. Now I'll start the update. Okay, so the firmware is successfully upgraded. Now we have to go to our console, and from here we have to first type mnemonic to generate a seed in our system, and then we can just okay, so this is our seed. If I do public keys, you can see the public keys, the machine ID and the address. So the concept about machine ID is that this machine ID is burned into this firmware, and in order to register this firmware ID, this can only be done through an OEM provider, and basically a company which owns this device. So if a hacker tries to hack this device and change the private key to its own, then it won't work, because this address and this machine ID are both linked with each other inside the Dataverse ledger. So if this address is changed, then the notarization will fail, and hacker cannot change this machine ID, because if it changes this machine ID, then this whole identity of this device will change, and this does not now it doesn't belong to this company, so still the data notarization will fail. So now we'll add few API keys in order to communicate with our Dataverse ledger. So you can see this is our Dataverse ledger. It's currently running. Okay, so this is our block explorer, and I'll also create terminal, and here we'll run our Dataverse ledger RPC APIs. Okay, so now we have to register this machine CID into our Dataverse ledger. You can see this is our device, and this is its machine CID or machine ID. Now we'll just quickly enter this here, and this step can only be done by the owner of this device, the company which is using data ledger. Now we'll quickly send the transaction, and you can see the transaction is successfully done. And here you can see, if I go to chain, if I go here, you can see this log has been generated by the Hyper SDK Block Explorer, which is pre-built. So here you can see the machine ID, and it is successfully registered to this account, which is our token, and this address, right? So now now the attestation is registration is done. Now we'll complete the attestation, and now we'll attest the machine. This step is basically mapping the machine address, which is the public address, with its machine ID, so that if the address changes, if hacker if the hacker steals the seed phrase, then it cannot regenerate this device, or if it changes the seed phrase, it cannot re-notarize from this same device. So we have copied this address and we'll paste it here, and we have our same machine CID and the manufacturer and the category, and we'll quickly, okay, so the transaction has been done. So you can see the transaction log here. So this is completed, and now we are ready for data notarization. So for data notarization, we have a command called, first we have to add Dataverse API here, which is for notarization, it's this one. And okay, so this one is the API, and we'll enter this here. So now you can see it is successfully added. I'll quickly drop down the notarization periodicity to 1 hour, which is basically every 1 hour the data will be notarized to the chain. So now you can see we have to notarize the data. So I'll quickly re-notarize. Okay, so now you can see the transaction, new transaction like is logged here. You can see the new transaction, and now we have successfully logged the data, or basically the CID, which is a content identifier for this this data generated via this device, and that CID is actually signed with the machine ID of this device. And now I can easily verify it using the command we have here. Using this HTTP method. So here we just have to add it here, and I'll quickly add backslash. Okay, so now we'll verify the data. So actually this is the data. So this is the CID which was generated for this data, which is notarized by this device. And this content identifier signed with the machine ID is logged to the chain, or notarized to the chain. So I've added the machine address and the data here for verification. This API is for verifier, or the person who wants to trade the data for native tokens. So here, so this is the data. Now I'll quickly click on send, and you can see the data is true for this CID, which is generated or logged into the data. If I go to the chain, you can see this is the 6E in the last, and if I go here, you can see it is the same content identifier generated for this. And if I change anything in the data, suppose I added 1 as a factor, and then I verify it again on chain, then it gives me false. So this is the whole procedure of using Dataverse Ledger, and it makes it very, very secure for data trading and data authenticity verification. Thank you.